Today we're going to look at transformations of quadratics. Before we dive right into transformations, let's do a couple explorations tying in what we already know about graphing quadratics. We are going to be working with the vertex form when we're doing transformations. So we'll begin by observing here once again the parent function that is centered about the 0, 0 as the vertex. We're asked to construct a new graph here. So we begin by observing that the vertex is no longer at 0, 0, but it's at the HK here, which is at 1, 0. So that means on the graph, our new vertex is here. And so once the graph is completed here, we have seen that the parent function has moved over 1 unit to the right. And so to explain what's happened to the vertex, we can say it's shifted right 1 unit. Without a graph, here's a new equation here in vertex form. And we know that we can look at the vertex because we have those skills and know that the vertex is at 2, 0. So from the parent, this graph has shifted to the right 2 units. And again, I need you to make the connection. What is it in the equation that tells us that? So I think we're getting pretty familiar that this value here is telling us that we're taking the vertex from 0, 0 and moving it over, in this case, to the right. So in other words, the h value in the equation shifts the graph either left or right. So notice when the equation is already in x minus h form, it's going to move it to the left. But if we had the x plus h, which is the double negative form of the expression, that's when it would move over to the right. So we have a shifting of the vertex, or the entire graph, happening here. So the two shifts that we've noticed so far, those are called transformations. It's a change in the parent function. All graphs originate from the parent function. So when there's a shift up or down, left or right, or if there's a reflection of a graph, or if the width of a graph is changed, those are all transformations of the original parent graph. So please take a minute here to jot down. These are the 3 basic transformations we're going to be analyzing today. Translations or sliding of the graph. I'm okay with using the words translate, sliding, shifting to indicate that. We've got reflections, which is opening downward for our parabola here, because it normally opens upward, and then there's a width change, sometimes wider, sometimes skinnier. Here's another quick exploration for the next type of transformations that I want to point out. If your equation is not written in vertex form, please take a minute to do that. It is worth the while because it's easier to see your transformation. Here the a value is 1. In x squared, without the parentheses, means that your h value is 0. And the plus 1 here indicates the k value. So here we have a vertex at 0, 1, which puts the beginning of the graph up at this point right here. So with this new parabola here, we'll note that the parent parabola has shifted up 1 unit from 0, 0 to 0, 1. And that's the explanation we have here. Shifts up 1 unit. Let's observe what happens here in this example. Again, in vertex form here, we have 1 x minus 0 again, squared minus 1. So our vertex is at 0, comma, -1, which is down here. And then from here, the parabola is going to open upward again. I'm just going to do a really rough picture there. So again, what's happened to the parent is we've had a shift downward 1 unit. So what is it in the equation that does the upward and downward movement? It's going to be this number right there. So in general now we know the role of the k in the equation. It's going to shift the up or downward motion of the vertex and the entire graph. So the k value is going to shift up or down. The h value is going to shift left or right. So without really graphing, we can analyze what the numbers are going to tell us in the vertex form. So here's our h value, and because it's the subtraction, we know that this graph is going to shift to the right 2 units, and it's going to shift up 3 units. So that is how the parent is getting transformed. It's going to move to the right 2 units, it's going to move up 3 units. Okay, you can take a break from writing for a minute here. I just want to review a quick concept. When we have our vertex form equation, we know that the role of A here does something special. In the parent form, or the parent graph, the A value is 1 here. And so we have a certain step that we're following when we're going over and up, over and up, over and up. So when A is different, you notice the changes. When the A value is greater than 1, like 4 or 2, the parabola is much more skinny than the parent parabola, whereas an A value like 0.5 or 0.25 widens the steps when we're graphing the parabola. So let's summarize all the important transformations that the A, H, and K does to the graph and have it all in one place. We have the A value. If it's positive, we know that the graph is going to open upward. We already knew that. If it's negative, it's going to open downward. So if you have a new equation and it's got a negative A, that's a change from the parent. The parent normally opens upward, so if you have a negative A, you're going to want to note that it's been transformed to open downward. That's technically called a reflection. We also have, if A is, well, let's start with equal to 1. We know it's going to be the same width as the parent. If the A value is greater than 1, it's going to be skinnier than the parent. If the A value is between 0 and 1, which it would be a fraction or a decimal, a value between 0 and 1, we know that the graph is going to be wider than the parent. And it's okay to use those words. Then we have the H value. So just to be clear here, if you have x minus h, we know that's going to be a shift to the right, whatever h units. Okay, and you do want to kind of use that kind of wording, shifting to the right, 5 units, etc. If you have x plus h, we know that the graph is going to shift to the left, whatever h units. Same thing with k. If you have a plus k, we know it's going to shift up, whatever k units. And if it's a minus k, it's going to shift down k units. So let's do a couple examples to apply that information without having to graph. So here's an example, 3 times x plus 5 squared plus 6. And I usually go left to right in the analyzing piece. So I'm going to start with the a value. The a is 3. It's positive. And I know that's not a change from the parent, but I'm still going to explain or describe what this graph is going to say. So I'm going to say this graph opens up. And the 3 indicates that it's going to be skinnier than the parent. So I'm going to say opens up and is skinnier than the parent. Then I'm going to look at the h, and I'm going to notice that it's a plus h here. So we know that the parent is gets shifted 5 units to the left, and it's also getting shifted 6 units upward, or up, because of the plus 6. And that's all that you're really asked to do here when you're asked to describe the transformation, is put the numbers into words. What is happening to the parent with all these changes in numerical values? And here's another example, negative x minus 2 all squared. So again, left to right, I'm going to start with the a value. I notice that the parent here is going to open downward because of the negative. And then I will talk about the width. The width has not changed. So I'm going to say it's got the same width as the parent because of the 1, right? That's a 1 here that's implied. Then I look at the h value. I notice that the graph is going to shift 2 units, and because it's subtraction, it's going to move to the right. And then I notice there's no k value, which means it doesn't have a shift upward or downward, which you don't really need to mention if it doesn't move at all, upward or downward, or you could mention and say it's got no shift up or down. But this is pretty sufficient here. So we have that this parabola is going to open downward. It's the same width as the parent. It's going to shift 2 units to the right. Another example, again, left to right, we look at the a value. We notice that it's a positive a, so it's going to open upward. But because of the 1/3, which is a fraction between 0 and 1, this parabola is going to be wider than the parent. There is an h and a k value. So according to the h value, this graph is going to shift 4 units to the right and 8 units down because of the minus 8. And that's it. The only other little thing I want to make sure I remind you of is if you're not given the equation immediately in vertex form, you're going to want to change it to that. So here, this equation here, you got your a value in front of the x squared. Notice you're not given the parentheses with the h inside, so what that means is your h is 0. So you're going to want to kind of rewrite the equation so it shows that, and the plus 1 is your k. And so when you interpret this, you're going to notice that this is telling you that your graph is going to shift downward. The 4 means your graph is going to be skinnier than the parent. And you don't have to mention that there's no shift left or right, but you're going to want to mention that it's going to shift up 1 unit.